Okay, good evening class o good morning class kung nasan man kayo dyan. Ito po ang inyong Pinoy Physics teacher. Oh, at kailangan po natin simulan na ang ating intro. Okay. So ngayon, ang topic natin is Coulomb's law. Second topic ko pa lang to sa YouTube na ginagamit kong means para makapagturo sa senior high for this COVID-19 period. Okay, so let's go now to the PowerPoint presentation itself. Okay. Coulomb's law. Ang prerequisite ng Coulomb's law is the study of charges. So that's my initial topic last time. If you hindi nyo nakita yon, makikita siya dito sa link. And then after which we proceed to the Coulomb's law. Automatic topic yan after the charges. So let's first start with the concept of table salt atoms. At why table salt atoms? Because table salt atoms are typically the molecule in itself does not really exist, but it exists as a series of alternating sodium and chlorine atoms to form what you call a cubic crystal. Now, this formation of atom is a curious one, no? On their own lang, without any interaction with other chemicals, they stand together, magkadikit, electrically neutral at all. However, kung ilulublob mo dissolve mo ang salt sa water, like this one which contains an H2O molecule, meron certain weirdness din kasi ang molecule ng water. Ang water kasi contains a large oxygen atom, and it's also this is a covalent combination. However, due to the arrangement ng hydrogen atom, medyo magkalapit yun na lang positive, and meron dito naka-exposed na side na negative. This is a polar molecule. So, merong slightly positive side at may slightly negative side. On the other hand, when you dissociate the salt atoms, mag-dissociate siya into individual molecules. Pero actually, hindi, no? Kasi, paghihiwa-hiwalayin yan ng molecules ng water. Yung water kasi itself polar, so it has the capability of pulling. Like this. So, it has capability of pulling the sodium and chlorine atom to make them dissociate in such a way that ang sodium atom, which is now, since naghiwalay siya, nawalan siya ng 1 electron, so which makes this slightly positive and attracts siya sa slightly negative na part ng water. Ang chlorine atom naman, which contains an extra electron, so therefore it's slightly negative and becomes slightly more attracted to the part of water which is merong hydrogen atom. Okay, so as depicted here, the location of the signs according to the law of charges as well as the law of conservation of charges. And neutral ang entire situation, but still they behave as if meron silang charges. It's because of the distribution of the charges. So, the dissociated sodium atom usually referred to as the sodium cation, and the chlorine atom is the chlorine anion. And together, they are actually bonded together using what we call the ionic bond. And these are called ionic bond because it forms charged particles pag nag-dissociate. And as well as ang ionic bond kasi is actually caused by the large differences of electronegativity of participating atoms. So, chlorine has 3 and sodium atom has 0.9. So, with a difference of greater than 2. Now, consider, for example, our first situation. Remember, our topic was charges. And let's say we have a Cartesian coordinate plane. Then, we introduce dalawang charges. Now, when I use blue, it means positive charge. Okay, they are both charged at 1 coulomb. And then they're placed on a on a coordinate plane with ang size ng unit niya is 1 meter ang kada unit. Okay, so we assign that Q1. Okay, and the other one is Q2. Then we drop that on their location. One is at negative 2 meters. The other is at positive 2. Okay, 2 meters away from the origin. The other one is 2 meters away. On the other direction, ang isang charge. And using the law of charges, what is the force that acts on charge Q1 from Q2 as well as on Q2 from Q1? So, yun ang tanong, no? So, anong answer dyan? Well, yung answer mo, therefore, is that since both charges are positive, merong repulsion between them. Okay, Q1 will push Q2, and Q2 will be pushing back Q1 as an action and reaction pair. So, showing it as an arrow, so 1 unit, this size of the atom is just, it's just a convention ko lang na pinili para madali tignan, no? So, the length of the arrow I showed here is supposed to be the reaction of the two. So, ang Q1, ang effect niya, lalayo siya sa Q2, and ang Q2, lalayo sa Q1. So, ang arrow is from the object, going away from the Q1. The other is Q1. The arrow is pointing away from Q2. Now, if the arrows are not placed properly, kasi for purposes of visual understanding, so if you remove the coordinates, this is how it will look. The arrows are pointing away. Now, this one will cause motion only if one of them at least is moving. Of course, pwedeng dalawa, no? Kung one of them is nakapako or nakapin sa wall or something, the other one is the only one that will be moving. Okay, situation number 2, if we change that to a negative sign. So, ano naman ang direction ng charges dito ngayon? Kasi negative siya, so we all know that pag negative, according sa law of charges, they will be attracting each other. So, Q1 will be attracted to Q2 and Q2 will be attracted to Q1. And since these forces are opposite, so we also, although opposite ang charges, ang effect ng force is not opposite. It's actually opposite in a way kasi nga meron siyang action-reaction pair. But the motion is towards each other. So, arrow-wise, without the coordinate system, Q1 will try to go to Q2 as well as Q2 will try to go to Q1. Now, this is supposed to be red. Okay, anyway. Bear in mind that these equal but opposite forces do not add nor subtract each other since they act on two different objects. Okay? Ang arrows, we just assign that as 1 unit long. Now, if magtatanong kayo, bakit sir, hindi pwede sila mag-subtract? It's because nga they're acting on the two different objects. The net force usually acts on one object. So, several forces acting on one object, they will tend to cancel out each other's effect. Although the forces are still there, they're just canceling each other. Ang effect. Okay? Now, this time, what we're going to do is we're going to try to predict the consequences. So, if we double the charge of the first case, what happens? How large would the vectors be if the first case charges were doubled? By retaining their distances at 4 meters, will it be longer? Twice? 3 times? 4 times? Ganon. In my drawing, possibly greater than 2. But we're not sure. How about naman kung ganon sa negative? Sa case number 2 in which negative yung isa, how long will the arrows be? Remember, the arrows represent the strength of the force. So, ang standard strength niya at a distance of 4 meters with 1 is just 1 arrow sign. Pero pag in-increase mo ang charge niya, instead of 1, gagawin natin 2. Hindi na reflect sa drawing. Anyway, di bali na. What happens? So, we predict the consequence of the double but this time, we retain the charges originally, pero we double their spacing. So, instead of sa 2, lagyan natin sa negative 4, the other one sa positive 2, sa positive 4. So, dinouble mo ang distance. Ang effect is that what? What happens? What happens to the charges? How are they going to interact? Will the arrows be half unit long? O 1/3? Let's see. Now, we do the same kung gawin natin Q1 negative. O, how much naman? Kaganina is positive pareho. Then this time, negative naman. So, how long will the arrows be? Will it still be half in length? And so on. So, to be sure of the answers, Charles Coulomb had similar questions in his mind and therefore perform an experiment to find the relationship of the forces between charges. Okay? So, meron siyang mga tenray na baguhin. So, tignan natin kung paano niya pinarform. So, here's a torsion balance this case. Let's see. Tingnan natin kung ano yung nangyari. Okay, this time he used a torsion balance. Now, magulo yung drawing tignan. Let me try to explain each one. It's actually based on, basically one large suspended rod. Preferably heavy one. Ang purpose is para pag sinabit siya with a strong, thin string, it will be stable enough. Hindi siya masyadong gumagalaw. And there's a mirror attached at the intersection of the strong, thin string with the balanced suspended rod. So, the rod has to be suspended in such a way na balance siya. Hindi siya magtitilt. Okay? And the mirror will serve as a reflector for light coming in to highlight a certain area of this calibration sheet. And then makita ng nagbabasa using a telescope then or a larga vista, usually binocular or something similar to that, monocular. So they can see the changes ng kapag nag-twist to. Now this basically parang imagine mo isang string lang siya, isang metal nakatali, then there are two charges placed. They are completely the same except that opposite charges. Then what happens when you place them all at the same time? What will this one? So, ang mangyari, this one will start tilting according to since positive ang nakadrawing dito, no? At saka negative. They will attract. So, the turning actually has to be equivalent to a force. So, it's a matter of ratio and proportion then. So, there's no specific reading dun at that time. It was done years ago, but hundreds of years ago. And he came up with this formula. The formula he arrived on is that yung force that which he attributed sa electrical force is basically proportional sa product ng charges and inversely proportional sa separation ng dalawang charges. And these charges are usually referred to as very tiny charges, so point charges sila. This one only tells you that this expression is a vector quantity. So the force is vector. So therefore, you can state this as the electrical force between two charges Q1 and Q2 is directly proportional to the product of the two charges, which is Q1, Q2, and inversely proportional to the square of the distance D between them. In this case, R ang nilagay ko, no? But you can actually use D, provided you put a unit charge D hat or R hat in this case. And this is called, okay, with the K sub E, which is currently measured at 8.988 times 10 to the 9 Newton meter squared per Coulomb squared, a rather complicated unit, set of units, and is called in honor of him, Charles August Coulomb. Okay, and he came up with this formula. So let's go back to case 1. In this case naman, if we have these two charges, Q1 and Q2, separated by a distance of 4 meters, ano yung force between them? Remember, when you measure that force, it can either be here sa Q1 or sa Q2 lang. And you're measuring equal forces. So, given Q1 and Q2 as 1 coulomb, at that ang distance between them is 4 meters or R, sometimes it's expressed as R, and the constant of proportionality 8.988 times 10 to the 9 Newton meter squared per Coulomb squared. What is the electrostatic force of repulsion between them? And that would be either from Q1 to Q2 or from Q2 to Q1. And so using this formula again, so we come up with the substitution. So, since it was already given that Q is just 1 coulomb, so we have 8.988 times 10 to the 9, hindi ko muna sinama yung unit, 1 coulomb times 1 coulomb divided by 4.0 meters, quantity squared. And you come up with 0.562 times 10 to the 9 newtons. Sounds small, but actually it's a large one. It's Teranewtons, or a billion newtons. Remember, ang isang kilo ng bigas is 10 newtons. So, imagine mo gano'ng karami ang Teranewtons. So, if we are to plot this on a graph, what will it look like? See? Ano kaya ang appearance niya, no? So, let's see. Oops. Baguhin mo natin screen into the Excel. Okay. Ito, nasa Excel na tayo. Now, here is the graph. So, nag-plot ako, nag-set ako ng force versus Q1, Q2. Meaning, I'm going to compare the product of Q1 and Q2, which happens to be the same. So, yung Q1 at Q2, kung 1 ang Q1, 1 din ang Q2, and so on. So, ang product nila is, for example, in this case, 1 times 1, 1, 2 times 2, 4, and so on. Then, using the formula of Coulomb, which we demonstrated how to compute, these are the forces that were taken, no? 5.618. And we assign that force with an arrow length of 1. Okay? So, kapag ang charge mo parehong 2, which is yun ang case number, susunod na case, diba? Ang Q1, Q2 would then be 4 Coulomb squared. So, the net force, the force acting on that one will be 2.24 times 10 to the 9, or about 4 times the length of the original arrow. So, meaning, ang tanong kaganina, di ba, is kung change mo ang 1 to 2, parehos yung charges, ano yung effect nun sa force? The force is multiplied 4 times. Pag dinoble mo ang ano, so, ang parehong charges, 4 times. Okay. But when you plot that, notice that this is a straight line. So, kasi F is directly proportional to the product of Q1 and Q2. So, therefore, you come up with a straight line. Next is, what if you plot force with distance, or with R in this case, no? So, if you have to consider a distance of 1 meter using consistently the same charge of 1 coulomb, or even 2, actually, pero in this case, 1 siya, you'll get this force. Ang length ng arrow, kapag ang distance mo is 1 meter, is 16 times longer than the original arrow. However, in our example, it's actually 4 meters. So, andito yung range ng answer. That's what we set as 1 meter long, ang 1 unit long ang arrow length. So, if you are to increase the distance from 4 to 8 or double mo yung distance between the two, you come up with a value of 1.404 or about 1/4 the length of the original. So, pag dinoble mo yung distance, the force becomes 1/4. Hindi 4 times, kundi 1/4. Magiging kalahati ng kalahati. And it is when plotted, of course, this one looks that way, no? Inverse square proportion na shape. Electrostatic force versus distance. So, it's based on that knowledge then, it's quite easy to understand that whenever there's a live wire na nakalublob daw sa may water, na may mineral, hindi ka madaling makuryente kung malayo ka. Of course, kung malapit ka, this ang effect. Pero kung malayo ka, the effect is this. So, it's mabilis siya mag-drop ang value. So, I hope you understand that part, yung pag-compute. Okay. I hope you understand this part, yung pag-compute niyan, as I've said kaganiha. What else can we do in this case, no? Next time, I'll be giving a series of examples of Coulomb's law, visually represented, as well as magko-compute tayo ng forces. So, in this case, hindi na natin kailangang maghintay pa ng matagal. But, I hope I can have the next example or the series of example here. So, we come up with